Hello, class. Welcome to week 2. Uh, I wanted to take a little bit of time and just let you know a secret of mine. I go back to the syllabus all the time. And so I'm going to go back to the syllabus right now and talk about week 2. When you go down to the breakdown, you'll see that discussions are worth 30%. You'll also see that assignments are worth 20%. And then you'll see exams are worth 30%, final exam is worth 20%. All that added up, all that adds up to 100. Last semester I had quite almost twice as many assignments. This semester I have fewer assignments, like half of what I had last semester, because I think I gave the students too much work. They did great, but I think it was too much work. So I'm backing off and I'm focusing on certain uh, chapters now that I'm getting more comfortable with teaching online. So in the syllabus, what I do every single week to give you a video is I go to the schedule part of the syllabus. All right? And that's what I recommend you do. I'm doing it on Canvas online right now. For example, under the schedule, you'll see the topic, the chapter numbers, and then a comment. Okay, so for chapters 1 through 8, um, the topic, we had a prelude in week 1, and then we started talking about Welcome to Earth, Science 1, and then we began part 1, Our Dynamic Planet. Excuse me. Then you'll see that under part 1, Our Dynamic Planet, we have chapters 1 through 8. And this week is week 2. So part 1 of the course will be covered in weeks 1 through 3. And then you'll see under the comment, it says that weeks 1 through 3. Then right underneath the words weeks 1 through 3, you'll see exam 1 is in week 3. I just wanted to make sure you understood that that's how to interpret the schedule in the syllabus. So go back to the syllabus often. I do it a lot. All right, so we're continuing to talk about Our Dynamic Planet. Excuse me. Okay, I had to take a pause, get my notes together. I wanted to talk a little bit about chapters 3 through 5 with you. We're going to explain the difference between rocks and minerals. We'll understand weathering, soil, and mass wasting. We'll continue to I'll continue to give you assignments. You may already see them. You could do all the assignments right now, but I highly encourage you to follow along. Take your time, spread this class out. Don't overdo it because you'll burn out pretty quick especially if you work all day and then you have family, whatever's going on in your life. Just take a couple of hours, like 3 times a week in this class. I know some of you have probably wait to the last minute. Don't do that. Each assignment has a due date. Okay, so continue taking the assignments throughout the semester. The discussions, as I mentioned already, are weighted quite a bit for your course grade. So don't blow them off either. They have a due date. Everything has a due date because I want to make sure you stay on track. I don't want you to wait the last minute. So I'm a pretty good guy, pretty nice guy. Just don't be late. All right? Complete everything on the due date, especially assignments, discussions, and exams. Your reading, that's really up to you. All right. So going back to talk about chapter 3, that's titled Introducing Minerals and the Nature of Rock. So by the end of chapter 3, I have a little post-nasal drip and I apologize for that. You'll be able to define the word mineral, again, I apologize, I had a little coughing spell. Alright, so you'll be able to define the word mineral. In the context of geology, a mineral is something special, very, very special in geology, and you'll be able to list the ways that crystals form. You'll be able to differentiate among different classes of minerals and recall that most of the earth consists of silicate minerals. You might be able to, with further study, examine minerals and identify their basic physical properties. No, we do not have a lab in this online class. However, if you take the time to understand different types of minerals, you should be able to identify them in the real world with a little bit of understanding of the basic physical characteristics. You should also be able to describe the various characteristics that distinguish types of rock. Rocks and minerals are two different words, first of all, and they really are two different, they have two distinctly different definitions, so they are different. You'll be able to list the ways in which rocks are made solid and coherent. And finally, I would like for you to be able to explain how geologists classify rocks into 3 groups on the basis of how the rocks formed. So I'm going to shape my discussions and assignments that way. If we move to chapter 3, you gloss through it as you read it. What is a mineral? Why is glass not a mineral? Some of the things that are going to pop up in there. You'll be able to understand what a crystal is. Some minerals occur as particular types of crystals, like euhedral or anhedral. So just get a basic understanding of crystals, minerals, rocks. Then hardness scale, these are different physical characteristics of minerals and rocks. How do you determine the hardness? How do you determine the physical characteristics? One physical characteristic would be acidity. You should be able to drop some vinegar on minerals and some of them will bubble because the vinegar and the mineral interact to create a weak acid, which causes it to bubble. Then you have many other physical characteristics which are in your chapter. There are other physical characteristics that I'm not going to discuss with you. When you put minerals under a microscope, it is like a wonderful world. You'd think it's a boring object, but when you put it under a microscope, you'll see a high, well-ordered crystalline structure for the most part. And what's the difference between soil or sediment and rock or mineral? There is a difference. So I'm going to take you through a little bit of that, give you a basic understanding. In San Antonio, Texas, and many parts of the world, we have crushed calcite. Calcite is the main mineral in limestone. Limestone is a rock. Calcite is a mineral. Again, chapter 3 is going to explain to you what the difference is. You'll also be able to understand what the difference is in the mineral calcite, for example, and the mineral diamond. Alright? I'm going to take you to chapter 4. It's volcanism and igneous rocks. igneous rocks, first of all, are formed through volcanism or volcanic activity. By the end of this chapter, you'll be able to explain why melting happens inside the earth, illustrate how molten rock rises and eventually cools to produce igneous rock, which differentiates between different compositions of magma. Through that, you'll explain the difference between extrusive and intrusive igneous rock, discuss why there are so many different types of igneous rock, some smooth, some coarse, some smooth or fine, coarse or fine grained, and they have different names because of that, and how we can identify and interpret them, distinguish among various ways in which volcanoes erupt, and explain why some produce rivers of lava while others explode to produce ash. Hawaii just gave us all, the whole world, a display of a river of lava. You'll be able to interpret the various hazards that develop during or after a volcanic eruption. Also, and finally, you can, after this chapter, evaluate how we can, to some extent, predict eruptions, mitigate volcanic hazards. It's a really cool chapter. Again, sorry. So, magma, terms like magma, lava, asthenosphere will pop up in this chapter. Crystals are formed with magmatic activity. Temperatures under the surface of the earth and temperatures above the surface of the earth render a different type of igneous rock depending on where the magma ends up. I want you to make sure you understand the figures that are in the book. What is a batholith, for example? What do we mean by plutonic? So those are just a few terms. And how does the bottom of the ocean, with magma coming up from the earth at the bottom of the ocean, how does it differ from excuse me, again, magma that reaches up through a mountain up, and then volcanoes erupt above the, on a continent? What kind of magma is that shapes an igneous rock versus the magma that erupts, a volcanic eruption at the bottom of the ocean, producing magma again and lava underwater? Though, what are the differences? We talk about that, about the decompression, the melting occurs, why we have different names. That is why we have different names. Subduction, get used to that word. Asthenosphere, get used to that word. All right. Asthenosphere is where we believe, theoretically, the magma is started from. Let's just put it that way. So where is the asthenosphere? Sphere, remember, that's like a ball. So the earth has spheres, and the asthenosphere is just one of them. So it's a very important part of the earth that creates our mountains, creates this special rock called igneous rock. And then we give different igneous rocks different names depending on where they form and how fast they form. The crystals form different time rates, etc. That's why they have different names. So the figures will really help you. There are different types of volcanoes that are defined as well. We give them different names because it's easier, quicker for one to understand how that mountain was formed, how that volcano was formed, if you give it a name which describes the process. Okay? Oh, there's so many mountain ranges. Just if you've ever been on a mountain, think about it next time. If you've ever been on a mountain, then you've been on a volcano. Mountains were formed by volcanoes, volcanic activity. Hey, had to let my dog in. I'd rather put my dog out when she wants to go out. Nature calls, right? So in chapter 5, this is the final chapter I'm going to talk about in this video for week 2, titled A Surface Veneer, Sediments, and Sedimentary Rock. Chapter 4 again discussed volcanism and igneous rocks. Chapter 5 discusses sediments and sedimentary rock. So through this chapter, you'll understand how weathering produces sediment at the Earth's surface and distinguish between physical and chemical weathering. That's why I want you to take what I call a virtual, and Pearson actually calls it a virtual. I'm sorry, I'm doing this really late at night. A virtual field trip of the Bisty Badlands. So it's a really cool field trip, and I am kind of, I don't know, making it short for you, shorter than it really is. So I've abbreviated the field trip. So you'll be able to explain how soil forms, how it differs from sediment and rock, and how environmental factors control its characteristics. You'll be able to describe how sediment transforms into sedimentary rock, list the key types of sedimentary rocks, and explain the basis of classifying sedimentary rock. The reason why I'm saying sedimentary rock so much is I want you to get used to igneous rock, sedimentary rock, and the final one will be metamorphic rock, which I'm not going to talk about tonight, but that would be the final major rock type. But in chapter 5, to bring it back to home plate, from first base, from home plate, first base to second base, third base, and back to home plate, you'll be able to apply your knowledge of how depositional environmental controls, how the depositional environment controls composition, the textures, and the layering of sedimentary rock to interpret an outcrop or description of sedimentary rock. Outcrop is first defined in chapter 4. So they all tie together, all these chapters. And by the time you get done with chapter 5, that means you've gone from chapters 1 through 5 within 2 weeks of this class. And you've actually, in the third week, you'll have gone through 8 chapters of this class. And but by the end of chapter 5, you'll be able to explain the concept of a sedimentary basin or a plutonic batholith. You will be able to. Plutonic and extrusive igneous rock, sedimentary basins. You'll be able to explain subduction zones, how the asthenosphere plays a role, and where mountain ranges exist, where the naked eye cannot see it. Mountain ranges at the bottom of the ocean. You'll also finally be able to explain why transgression and regression occur in sedimentary rock, sedimentary basins. Are there any questions? Yes, you over there at the back of the class. Oh, that's right. This is a virtual class. So if you do have any questions, feel free to ask me, email me. I do have a Skype. I don't know much about Skype. I don't know if you're into FaceTime or something like that. But all I have is a personal cell phone, so I'm not going to give that out to you. I hope you understand why. But I do have a Skype account. It is CarRDJ3, CarRDJ3. CarR, my last name, D as in David, J as in James, Dave James Carr, 3. And the 3 is just to distinguish it. There were 2 others when I created the account. Alright, so CarRDJ3 is my Skype account. And you know, maybe you should email me and we can figure it out. But there's also Collaboration Ultra in Canvas. If you want to set up something, I can give you a phone number. We can both call into it. It's like a conference call if you're used to that. I can do that too. That's easy peasy. So just let me know if you want to talk. Um, Anytime. We can set it up and I'll do my best to make it as easy for you as possible. All right? So please ask questions and I will do everything in my power to respond to you as fast as possible. Okay? And even, like I said, one-on-one. And in the remote chances that you need to actually have a face-to-face with me, if you live in the San Antonio area, I meet with students uh, at 5:30 on Thursdays, 5:30 p.m. on Thursdays, Central Time, 5:30 to 6. Just it would be nice if you let me know you're coming, but if you don't let me know, I'll be there. If you don't see me right away, I'm sorry. It's because I'm upstairs or I'm downstairs. I'm checking mail, but I'll be back quick. All right. But I make sure that I'm there at 5:30. I'm usually there a little bit earlier. All right, take care.